Let us now proceed to Module 1, the origin of our planet Earth. But before that, we will discuss first the formation of the universe. So we have our learning competencies. At the end of this lesson, you will describe the historical development of theories that explain the origin of our universe. Compare the different hypotheses explaining the origin of the solar system. Formation of the universe. The science of cosmology provides several hypotheses explaining the beginning of the universe based on the present physical and chemical properties of the universe. So cosmology is the science that study the origin or the formation of the universe. And there are theories or hypotheses that try to explain the beginning of the universe. There are numerous versions, but the most widely accepted ones are based on current scientific observations. So when we say current scientific observations, the evidences is truly happening in the real world. It is being observable until now. So we have the first one, the Big Bang Theory. So it is remains to be the top prevailing cosmological model for the development of the universe. It provides the best explanation and implicitly accepted by majority. So, in the recent past, astronomers predict their new findings on the beginnings of the universe through CMB. So, this cosmic microwave background is the first glow or the first light of our universe. It is a background radiation. So some scientists speculated that through the CMB or the cosmic microwave background, this evidence is when the universe was young. Before the stars and planets even existed, the universe was denser and hotter. So it is very dense, no? And very hot with extreme temperature. So at around 5.5 billion degree Celsius and filled with a uniform glow of hydrogen plasma. So it is being determined that all stars, galaxy, and other celestial bodies is made of this hydrogen plasma. The universe was also contained the basic particles of neutrons, electrons, and protons. In the very beginning of the Big Bang, we have the so-called singularity. It is a single point wherein it is very hot, it is very dense, and it is very small. And the first 3 minutes of the Big Bang, the elementary particles of matter, just like antimatter and dark matter, creates the first proton and neutron and electrons. But because of the very high or intense temperature, it cannot create the first atom. Then the space expanded and cooled because of the expansion. So in this case, no, it can create the first atom because it is being cooled because of the rapid expansion. So when the universe got cooler, the neutron, electron, and proton particles decayed or combined to form the first atom. Over time, those particles created neutral atoms which allowed light to shine. So this first light is what we call the CMB, or the cosmic microwave background. It is the early light or the early glow or a baby picture of our universe. So it is being known as the afterglow of the Big Bang. In our picture, this is the picture or image of the CMB, or cosmic microwave background, also known as the baby picture of the universe. So each dot that represents as a quantum fluctuation in the afterglow of creation. So a quantum fluctuation is the science of a very small matter or very small energy that is rapidly expanding. So the expansion is because of this. It can also create the other celestial bodies, just like galaxies and other galactic clusters that we see today. So the CMB was believed to have been released 380,000 years after the Big Bang. So in 380,000 years, the temperature cooled down. Therefore, the clumping of particles formed the stars, or the first stars and the galaxies that we have now. So in the recent measurement of the age of the universe, it shows that it is actually 13.82 billion years old, not 13.7 billion years old. In our picture, we have the rapid expansion that happens in the singularity or the quantum fluctuation. So it creates inflation or continuous expansion of the universe. After that, it also signifies the creation of the elementary particles of matter, the dark matter and the antimatter, that creates the first atom. The first atom that is composed of electrons, protons, and neutrons. And after that 380,000 years, the first CMB was released, or the cosmic microwave background, the afterglow of the Big Bang. And then eventually first stars appear after approximate 400 million years. And after that, galaxies and planets develop as the universe continues to expand. And as the time goes by, dark energy drives the continuing expansion. So our universe is continuously expanding based in this theory, the Big Bang theory. So we have the history of the Big Bang theory, or the discovery of the Big Bang theory. So in 1910s, Visto Slipher discovered that the galaxies are moving far away from the Earth. When he saw the spiral nebulae is the first notation for galaxy. So the spiral nebulae was moving away from the Earth, but he did not know what is the reason why. He used a telescope observing the spiral nebulae. So in this case, no, Vestus Sliper, an American astronomer, was born in November 11, 1875. Sliper worked at the Lowell Observatory in Flagstaff, Arizona. And in 1912, he was asked by the founder and director Percival Lowell to measure the Doppler shapes of the most prominent spiral nebulae. So he used the observatory 24 inches Clark refracting telescope. So a Doppler shift is a displacement of spectral lines caused when the object you are looking at is moving toward or away from view. So in Doppler shift, we can eventually see blue shift and red shift. So in red shifted nebulae, when we describe the red shifted galaxy, no, that galaxy is um, moving away from the Earth. And when it is blue shifted, no, the nebulae is not moving, no, the stars is not moving fast. So a Doppler shift is a displacement of spectral lines caused when the object you are looking at is moving toward or away from you. Motion towards observers produces a movement of lines toward the blue end of the spectrum. So the spectrum is what we see when we use a high-powered telescope. So while motion away results in a redshift. So that is why when we recognize redshift using a powerful telescope, no, that redshift object in the spectrum, we determine that the nebulae is moving away from the Earth relative to the Earth. It was expected that the motion of spiral nebulae would be random and that redshifts and blue shifts would be present in equal numbers. So means to say, no, may nakikita si Vestus Sliver na mga spiral nebulae na blue shifted. Yun yung hindi gumagalaw or slow yung kanyang movement away from the Earth. Pero meron din siyang nakikita ang mga galaxy na they are moving fast away from the Earth. So Sliver started with the largest nebula, the Great Spiral in Andromeda. So the Andromeda galaxy is the neighborhood of our galaxy, the Milky Way, and found that it had a blue shift. Kaya malapit dito yung Andromeda galaxy. Kaya pag tinignan natin dun sa telescope, no, hindi siya gaanong gumagalaw or hindi siya lumalayo talaga sa atin. So blue shifted siya dahil malapit siya sa ating galaxy na Milky Way. But the other galaxy is moving fast, no? So yung nakikita sa spectrum ay naka-red shifted sila, corresponding to a motion towards us of some 300 km per second. But as he looked at the other spirals, he found that the Andromeda was exemption. Nearly all of the other nebulae exhibited red shifts. So, ibig sabihin, karamihan sa mga inobserve niyang nebulae or galaxies ay lumalayo sa atin, lumalayo sa planet Earth relative to the Earth. Some of them quite sizable. There are large and small galaxy or spiral nebulae observed by Vestus Sliper. So Sliper announced that the result of 15 nebulae in 1914 to to 1912 were moving away from us. And for a total of 25 nebulae in 1917, 21 had redshifted. So we see in our image, in our table, in 1917 table of nebulae, they are being redshifts in our second image. The ones with the greatest redshifts are moving away from us at speeds up to 1,100 kilometers per second. Okay, so that is equivalent to 684 miles per second or 2.5 million miles per hour. Next, we have George Lemaitre, expanding universe. So after the discovery of Vestus Sliper in 1910, in 1927, George Lemaitre proposed an explanation that he thinks that the reason why the spiral nebulae are moving away from the Earth because the universe is expanding or continuously expanding. The expansion of space occurs between the Earth and the other galaxy. So, for example, no, inflating a balloon with dots. Now, when we inflate a balloon, so we are reducing air inside the balloon. So when we draw dots, no, the space between the dots, between two dots increases. So that is the best example to describe Lemaitre's theory of the expanding universe. So, after the discovery of George Lemaitre, 2 years after that, in 1929, after George Lemaitre proposed his theory about the expanding universe, Edwin Hubble discovered that the movement of galaxies away from the Earth are relative to the Earth using the Hubble's law. Ibig sabihin, lahat ng galaxies, they are moving away from our planet Earth. Walang lumalapit sa planet Earth. Lahat ay lumalayo. No one will come close to the Earth. It means to say that the universe is continuously expanding. So therefore galaxies are moving away from us, and then galaxies that are farther away are moving faster than those galaxies that is nearest or nearer from our planet Earth. So the expanding universe is just like in the every raisin in a rising loaf of raisin bread. So we can see that every other raisin is expanding away from it, so relative to the center of the raisin, no? Yung mga raisin bread, no, they are expanding away. So the Hubble's law has a formula of velocity equals to the Hubble's law times distance, wherein the Hubble's law is equivalent to 71 kilometers per second. So the discovery of Edwin Hubble had determined the distance to many of the spirals, now known to be galaxies. He realized that the farther away a galaxy is, the faster it is moving away from us. In mathematical form, this becomes the Hubble's law, and in popular form, it became the discovery of the expansion of the universe. So it was announced in 1929, and it is one of the great discoveries of modern cosmology. Don't forget to like and subscribe to our channel.